Today we are going to discuss a topic queue using stack, where we have to implement the concept of queue using stack. My name is Asmita Dikshit and I am assistant professor in the Department of Information Technology, ABS Engineering College, Gaza. The concept of queue using stack is a method of implementing the process of first in, first out by the use of two stacks. That is, we have implement the concept of first in, first out. But this time we don't have to implement this concept by queue. Instead, the operations will be NQ and DQ, but we have to use the concept of stack. Here we will be requiring two stacks. How it will be done? In the first stack initially, that is the first stack, the elements will be stored in the last in, last out pattern. Now, the elements of the stack 1 will be copied to stack 2, which will again reverse the element order. What it is saying? It is saying that if I will be using two stack, what will I do in the first stack initially? The elements, suppose 10 is inserted first, then 8, then 24. So elements are stored in, last out pattern. After that, the elements of stack 1 will be copied to stack 2. So what will be copied first? 24, then 8, and then 10, which will again reverse the element order. Now, if we pop out this element, the element that was inserted first is deleted first. So first in, first out, if we are using two stacks S1 and S2. Ultimately, when the element popped out from stack 2, they will be displayed in the same order as inserted. The algorithms for this is as follows. The first algorithm will be initialization algorithm. We'll initialize two stacks, stack 1 and stack 2. The two stacks are named as S1 and S2. The output is nothing in this algorithm. Only we have to initialize top 1 of S1 as -1 and top 2 of S2 as -1. This indicates that both my stacks are empty. Then we will prepare an isEmpty function to check whether every time we are trying to perform any operation from stacks, we should be very clear whether there is any element existing in the stack or not. So for that, we are checking isEmpty function. The input will be two stacks named S1 and S2. The output will be true and false. If my both the stacks are -1, the top of both the stacks are -1, that means my stacks are empty and we have to return true. Otherwise, the stack is not empty and we have to return. Let's see the NQ operation. In NQ operation, we'll be having an element and we'll be having a stack 1. The element that is to be inserted and stack 1 for performing the operation of NQ. So the input will be stack S1, data element for insertion X. There are two parameters. The output will be updated stack 1 after insertion. What we are supposed to perform in the NQ operation? We are supposed to push elements in stack 1 every time an NQ operation is called. Stack 1 is going to have an element pushed on it. Again, I call the NQ operation. The top will be incremented. And next element X, whatever has been passed, let's say 8, will be pushed in our stack S. Now suppose we have to perform the DQ operation. Now if I perform the DQ operation, that means the element inserted first is 10. So the output should be 10 of my DQ operation. Then the element inserted after 10 was 8. So our next deleted element should be 8. Let's see how this is being done. So this is our NQ operation. We inserted 10 first in our stack 1. Then we inserted 8. Then we inserted 20. Every time we call the NQ operation, one element is pushed on stack 1. So what will be the time complexity of our NQ operation? Since our push operation is only taking theta 1 time, so the time complexity of NQ operation will be theta 1. And we are not taking any auxiliary space in this algorithm in NQ operation. So the space complexity of this operation will also be theta. Let's see the DQ operation. In DQ operation, we'll be requiring two stacks. Why? Because we have to delete the element that was inserted first in our stack. That is, uh, after we have seen the algorithm of DQ, the first element that should be deleted should be 10. Let's see. The input are two stacks S1 and S2. The output is every time an updated stack S2. Now we'll check the isEmpty function. That means we came for deletion of elements in stack, whether there are in queue, whether there are elements to be deleted or not. If our isEmpty function will return true, that means our queue is empty. That means in this case, both stacks are empty and we have to exit. If this is not the case, then we have to come to the else part. What did we see in the else part? We are supposed to pop all elements of stack 1 and push into stack 2. So until our stack 1 is not empty, we are supposed to push elements in stack 2. And what will be that element? Every element that is popped from stack 1. So suppose, what is this saying? If this is our stack 1, it will check whether it is empty. No. So until our stack 1 is not empty, till the time our stack 1 is not empty, push in stack 2. What are we supposed to push? The popped item from stack 1. So until this goes empty, the popped item will be pushed into stack 2. Okay. Now, whatever is there on the top of stack 2, we are supposed to pop out and keep it in a variable, say y. So when we'll return y, this y will always give the value which was inserted first in our queue or in our stack, because we are implementing the concept of queue using stack. After this, when we have stored the top element on y, we will again pop back or push back all the elements of stack 2 onto stack 1. So we'll again push back all the elements of stack 1 until our stack 2 is not empty. So until our stack 2 is not empty, we will again push back all the elements back to stack. Why are we doing this? Because we are calling DQ operation only one time. Now, when we are calling it, when we're calling it for the other time, again we will push back all the elements of stack 1 onto stack 2, and the next inserted element, that is 8, will be popped out. Now, once we have done with this, we will return y. So this time our y will return 10 as per the example taken over here. So this part of the algorithm is checking in case both the stacks are empty. This part of the algorithm is popping out all the elements of stack 1 and pushing them onto stack 2. And this part is storing the removed element of stack 2 into a variable y. Then again we are popping back all the elements of stack 2 until it is empty back onto stack 1. And then we are returning y. So this return y is returning the element inserted first, just like the concept of queue, that is first in, first. So the time complexity of push operation in DQ operation is taking theta and y, because there are two while loops attached with both the stacks S1 and S2. So the time complexity of DQ operation will become theta n. The space complexity will also be theta n, because we are taking an auxiliary space S2 and we are copying all the elements from S1 to S2 and back to S1. So again our complexity is going to be theta n. So we are taking an auxiliary space as well. These are the steps what we had done. We are copying all the elements from S1 to S2. This becomes in reverse order. Then we are deleting or we are popping the top element. So this element, when we were enqueuing, this was inserted first. So when we are dequeuing using stack, this should be popped out first and it is being done. After that, we are again transferring back all the elements in S1. Why are we doing so? Because at a time we'll be calling either DQ function or at a time we'll be calling either NQ function. So the references taken are Geeks for Geek site, Prep Insta site, and the standard book Lipschutz Schramm series. Thank you.